You know, we've talked a lot about how power plants utilize heat and water as an intricate part of the process. But how do they stabilize those systems? Ladies and gentlemen, in this video, I'd like to introduce you to the cooling tower. See, we're currently in the basin of one of four quadrants of this facility's cooling tower. And while it looks like these are all structural steel beams, these are in fact fiberglass. Most of the cooling tower is built with concrete, fiberglass, or wood. And while the purpose of a cooling tower is a little bit self-explanatory, how it actually goes about providing that service is a lot more intricate than people think. If you look behind me, you'll see two large inlet pipes. These are the return flows from the equipment out in the field. When water flows towards the top of each tower, it will then come down and fall through what we call the honeycomb. This maximizes surface area so that the updraft can pull as much heat from the water as possible. Now, cooling towers are usually one of two designs. You can either utilize a natural updraft. These cooling towers are usually quite large in size, or a mechanical updraft. It could be any size, and they utilize a fan to push air up and out the top, thereby drawing air in from the sides and up through the honeycomb. This tower utilizes a mechanical updraft, and the fans are located right here.
Now, regardless of the design, the objective is still the same. Maximize the surface area of the water so that the upward moving air can extract as much heat as possible, allowing the water to be recirculated through the system.
After the water accumulates at the basin of the cooling tower, it will then be picked up by one of two pumps. These pumps send water to two separate and distinct systems. The first system, being a typical cooling water system, supplies equipment such as the screw ash cooler, the boiler feed water pump, the bearings for the PA and SA fans, as well as the oil cooler for the turbine itself. The second pump, known as the circulating water pump, supplies a mass amount of water to our condenser. Now, if you remember from our steam cycle video, the condenser is responsible for cooling and pulling all the heat from the steam after it's left the turbine. That steam then comprises back into condensate, which is just the purest form of water located in the hot well, and then reused throughout the cycle. Well, we need to extract a lot of heat, so we need a lot of water. These pipes right here are roughly 24 inches in diameter, both inlet and outlet. As you can imagine, a lot of volume of water goes through this condenser. Now, we hope you've learned something today. I know cooling water can be kind of a bland subject, but it's definitely one of my favorites. Join us next week when we have a one-on-one interview with the site's lead control room operator and have a discussion on what it takes to run a site like this. Thanks again for watching. We'll see you next time.